Hi, Calculus 1 students. So we're looking right now at higher derivatives, and there's two parts in this rather short section. One part is really finding patterns, which is what this exercise tackles. And you will also have a YouTube video in the other part, which is kinematics, pretty much like velocities and accelerations. So we have a function that's sine of 3x, and we would like to find the 27th derivative. Okay, so just I want to remind you that this is notation. So notation for h27 of x. So the 27th derivative of x. Okay, I just throw it in because you need to be aware that I could also ask the notation like this. And obviously, we're not going to take the derivative 27 times. You will see that actually 5 times is enough. So let's go. You take actually, let's write h of x, and you will soon see why I'm rewriting h of x. It will become relevant. H prime of x will be equal to, so using the chain rule, this is probably the only one I will do rather slowly. So using the outside rule, there you go. It's going to be the cosine of 3x. So cosine of 3x times 3, the derivative of 3x. Okay. So, and actually, yeah, let's just write it like this. Okay. You take the second derivative. Okay. And now you've got to be careful, okay? Because the derivative of cosine is negative sine of 3x times 3, okay? So it doesn't change right here. But you multiply it with another 3. Okay, so in other words, what you end up getting is negative sine of 3x times 3 squared. Okay, now you have to keep your eye on the ball on this point, because look, at the first, like h of x, you have like 3 to the power of 0. Here you have, so I'm going to rewrite it. Here you have like cosine of 3x times 3 to the power of 1. And here you could write 9 if you wanted to. But if you can identify a pattern, it's actually better to write the pattern. So that's why I'm writing 3 squared. Let's continue. H triple prime. So we take the derivative of negative sine, right? And the derivative of negative sine will turn out to be negative cosine of 3x. Okay. And now I'm actually gonna use the pattern that I have. I'm just gonna confirm it. So I will have an extra 3 that comes in from the outside-inside rule that multiplies with this 3 squared to give me 3 cubed. Okay? So here I'm combining the 3 that I get from the chain rule with the other 3's that I had already. Then the fourth derivative, so the derivative of negative cosine is negative of negative sine. So in other words, we will have here sine of 3x. There we go. Okay. Multiplied with 3 to the power of 4. Okay. And here's the magic trick. So what you should notice is that we have the same function that we had at the beginning, but taking 4 derivative has the effect of just multiplying the function that we had at the beginning by 3 to the power of 4, okay? So in other words, every time you take 4 derivatives, you're going to end up multiplying the function h of x by 3 to the 4. and you can obviously generalize this. So let's say you want to take 8 derivatives. Taking 8 derivatives will create this loop twice, right? And it's easy to see because it means that you're taking 4 derivatives of h to the power of 4. Well, not h to the power of 4, right? The fourth derivative of x. So what's going to happen? You're going to take 4 derivatives of 3 to the power of 4 times h of x because you're using now this formula. Now you're going to get here 3 to the power of 4, and taking 4 derivatives of h of x will bring you another 3 to the power of 4 h of x. So in other words, you will have 3 to the power of 8 times h of x. So what did we discover? And we could prove this fairly easily. We discovered that if the number of derivative is a multiple of 4, then we have this very convenient rule. So if the number of derivatives is a multiple of 4, it means that, actually, let's write it like this. If the number n of derivatives is a multiple of 4, then we know that hn of x will be equal to 3 to the power of n times h of x. So be careful, it only works if the number of derivative is a multiple of 4. So this rule here is not general. But if it works, then we can apply this formula. I can erase this because that's how we discovered that formula. That we call this a pattern. So logically speaking, we have 27 derivatives to do. So the idea is to take the closest multiple of 4 that is under 27. So we start taking 24 derivatives. Okay, so closest lower multiple of 4. So what I mean by this is that we have that h24 of x is equal to, so it's going to be 3 to the power of 24 multiplied by h of x. And then obviously you take 3 more derivatives. Then take 3 more derivatives. Okay, and by the way, these 3 derivatives were already taken down, so don't take them again. So what do we mean? We have like h to the power of, well, the 24 derivative, the 27 derivative of h, in other words. So yes, the 27th derivative of h is going to be 3 to the power of 24 times h prime 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 of x, right? This is the extra 3 that I'm talking about. And we found that out. Okay, so you're going to have 3 to the power of 24. And what we found out, unfortunately, I had to erase it. was that this third derivative was negative cosine of 3x times 3 to the power of 3. Okay, remember, it's what I erased. Now, of course, you have to simplify your answer. So your final answer is going to be 3 to the power of 27 cosine of 3x. And that's it. I hope this helped. So see you in the next class or in the next video.